really mean? So biotic factors are the living biological factors that may influence an organism. So predation, parasitism, disease, competition. All of these have discrete definitions that you need to know for topic 2.1. However, the abiotic factors, these are the non-living physical factors. So things like temperature, salinity, pH, sunlight, precipitation, wind, even the geology in the area, all of these things have an effect on what organisms can actually survive in that environment. So first of all, let's think about abiotic factors. Well, as well as affecting plants and animals, they actually interact with each other as well. So the interactions can create an abiotic factor of itself. So temperature depends on the amount of solar radiation, the wind speed, the time of year, the time of day, altitude, aspect. So all of those things affect temperature. But temperature itself affects the amount of water loss, respiration and photosynthesis that a plant can perform. And changes in the temperature affect then abiotic factors. Changes in the temperatures might affect the relative humidity, evaporation from the soils and water surfaces. So these interactions play out against each other. This leads to a unique set of conditions inside any environment, and species are adapted to be inside that environment, inside their niche. So, three quick examples of that. Three very, very simple diagrams. One of the floor of a tropical rainforest, one of the floor of a temperate forest, and one of a rock pool. They're very, very different environments, and they're different environments because of these interactions between the abiotic and biotic factors. So let's have a look at some in slightly more detail. So let's consider tropical rainforests. So inside tropical rainforests, the dominant species are trees and vines. Yeah, they reach very high up into the canopy. They create a three-dimensional structure as well. So tropical rainforests have a three-dimensional structure. Not only do they have breadth and width, they also have vertical height. So that vertical height allows them to have a range of different layers. They have a floral community, a plant community that's not the trees. And because of this range of different environments that are provided by the dominant species, we get high biodiversity. The same with the faunal or the animal community. We get very, very high biodiversity because we've got different layers in which different species can actually survive and live in individual niches that are separated from each other. And our soil community is very, very rich in decomposer species. There's a lot of decomposition happening there. So we've got a very, very rich biotic community that are interacting together. In terms of the abiotic conditions, well, automatically we think of temperature and rainfall as being controllers. Now, I've added a slightly different example to ones that quite often come up. This is from a tropical rainforest in Peru, and this is real data. As you can see, the Peruvian tropical rainforests are a little bit different. They actually have slightly and only slightly lower temperatures and slightly less rainfall in June, July, and August. That's actually because their rainfall and temperatures are affected by cyclonic systems in the Pacific Ocean. But generally, tropical rainforests have very high temperatures and very high rainfall. But there are other abiotic conditions as well. Humidity and light alter throughout the canopy. At the very, very top of the canopy, the humidity is lower than it is at the bottom of the canopy, and the light that enters is actually much higher. The bottom of the canopy is exceptionally dark compared to the top of it. So this gives rise to more layers of possibilities within the tropical rainforest. So you get many more niches. Any organism that lives on the forest floor in the rainforest has to be able to survive in quite low light levels. So you don't get many plants actually on the forest floor. All the plants that are found in tropical rainforests tend to be what are called edaphytes. They actually live on the sides of trees. So you get lots of plants actually living in different layers. Also, humidity changes. At the very, very bottom of the rainforest, on the ground layer, the humidity is very, very high. This leads to very high decomposition, whereas at the top of it, whilst the humidity is still high, it's much, much lower. So you get these changing layers throughout the canopy. So what's the effect of this overall? Well,